I need to find out the factorial of n. This n can be anything. This n can be anything. Okay. Okay. So now what I know the recurrence relation is nothing but I can say n into, let me at very first write n into n minus 1 factorial. It's n minus 1 factorial, right? The recurrence relation is n into n minus 1 factorial. Now here, this is pure mathematics. Now here I'm just converting this into code. So I can say, I can write n because n is a value. But how can I write n minus 1 factorial? I just can't write n minus 1 factorial here, right? So what I have to do? I have to just convert this into code. Now here comes the recursive solution or the recursion. What recursion says? It says, I will call a copy of myself. I will call a copy of myself with a different value. Okay. So what is this function doing? This function is finding out the factorial value of n. Okay. If this function can find out the factorial value of n, can I say this function can also find out the factorial value of n minus 1? Correct? I can do say that, right? If it can find out the factorial value of n minus 1, can I say it can find out the factorial value of n minus 2? Like this. If you see, the function remains same. The function remains same. Just the value I am changing. Right? Just the value I am changing. Okay. So what is this? What is this? This is a factorial. N minus n into n minus 1 factorial. Now I am finding out n factorial. Now I am finding out 5 factorial. 5 into 4 factorial. So this is the formula. This is the formula of finding out the factorial, right? So if I have to find out the value of 4 factorial, I am going to use the same formula, same pattern, that 4 into 4 minus 1 factorial. Correct? 3 factorial equals to 3 into 3 minus 1 factorial. So this is the pattern. Correct? So here the pattern is n into, and if I have to convert that into code, so what can I say? I can say it's n into f of n minus 1. F of n minus 1. So I am calling the same function. I am just calling the same function. And I am passing a different value. Right? I am passing a different value. And I will just simply return. Okay. Now we will see how this recursive function works and how the calls are going into the stack. Okay. So, okay. Now I have not written the base condition. I have to find out the base condition. What is the base condition? We will see. Okay. So now suppose this is my function. My function ends here. Now I have a main function here. And from the main function, I am calling f of 4. Okay. I called this function and I passed 4 there. Okay. So this function, okay, I have the main function here. Now after that, I have f of 4. Correct? The f of 4 gets called. Okay. The f of 4 is in the stack. Now I will check. What I will do? This is my function body. This is my function body. Okay. Here I will get return n into f of n minus 1. Okay. I will write this statement. I will write the whole statement. N into f of What is n? What is the value of n now? It's 4. So 4 minus 1, 3. Okay. Now I am going to call. Now this f of 3 gets called. That means the same function gets called with value 3. Okay. Now it will come here to the last line and it will call same n into. So n is nothing but, okay. So here what was the value of n? It was 4, right? It was 4. 4 into f of 3, correct? Now what is the value of n now? So this function has get called now, right? This function has get called now. Now this function has get called. So it's, what is the value of n now? It's 3. So can I say it's n into, that is 3 into f of 2, correct? Now I have called f of 2. This function has get called. Now what is the value of n? It's 2. Okay. Now it will come here and we'll see 2 into f of 1. Okay. Now can I say that this will be my base condition? Because I told you that when, because I know the value of 1 factorial. What is the value of 1 factorial? It's 1. It's simply 1. Okay. So this will be my base condition. That base condition is nothing but the smallest unit of recursion of the smallest problem that I can break down to. Base condition signifies the smallest problem that I can break down to. Okay. So here in our case, what is the smallest problem? It's 1 factorial. It's 1 factorial. This is the smallest problem. And I know the value of this, and that is 1, and that is 1. Okay. So I can say if n is equals 1, if n is equals 1, I will return 1. This is my base condition. Now this function has get called, okay, with the value of 1. Now I will check what is the value of n. It's 1. Is 1 equals 1? Yes, 1 is equals 1. Then return 1. Then return 1. Okay. So this function is complete now. This function is done now. And what is the value it returned? It returned 1. So this function has returned 1. Okay. Now what is the value of, what we have? We are going to do 2 into f of 1. It was 2 into f of 1. F of 1 has returned 1. Now I can do 2 into 1, that is 2. 2 into 1 is 2. And who called this? Who called this recurrence relation? This is the recurrence relation, right? Who called this recurrence relation? This f of 2. This f of 2, right? So I will return 2 to f of 2. Okay. I will return 2 to f of 2. Now I can say, now if you see here also I have returned 2 here. Okay, I have returned 2 here. So now I can do 3 into 2, that is 6. 3 into 2, that is 6. And who has called this recurrence relation? Who has called this recurrence relation? It's nothing but f of 3. It's nothing but f of 3. Okay, return 6 to f of 3. Now f of 3 is also done. What I will do? 4 into 6, it's 24. Now who has called this recurrence relation? It's nothing but f of 4. Okay, return 4 into 6, that is 24 to f of 4. Okay, now who has called f of 4? It's the main function. Okay, return 24 to main function. So now in main function, if I just take a int variable, int result equals to f of 4, you will get 24 in this R. This is how recursion works. This is how